Hello everyone, this is me Sorodev from Dev.com, and in today's video I am gonna teach you how you can create a simple artificial neural network from scratch, actually not from scratch, using Keras APIs, and you will be coding along with me, and we will be doing the credit card customer churn prediction project. It's a kind of mini project, and we will see how the model is created, and we will predict for a value and everything regarding the Keras API, TensorFlow Keras API. So, let us start. Before starting, I would recommend you to download this from Kaggle, this dataset from Kaggle. You can just click on download and see download as zip, and then extract as a CSV and keep it in your folder where you will be coding stuff. And also before coding, just install this extension from the extension tab, and this extension allows you to write Jupyter notebook in your Visual Studio Code, and that's it. Let's start by creating a notebook and then setting the and after that you have to create, you can create a virtual env using the command, I guess. Let me see, yeah, env python one second. Yeah, you can use, yeah, using this command you will be able to create a virtual env, and after you have created your virtual env you can name it anything, and you have to set the interpreter as the virtual env is python, and then you have to install this four packages, 4 modules using the pip install minus -r requirements.txt, and after that you are ready to code. I have attached all the files along with the requirements.txt in the GitHub in the description. So do check out my repository, and you can just git clone it and play with your code, run the requirements.txt, install the requirements.txt, and many more you can do with just visiting, after just visiting my repository, and that's it. Let's, without further ado, let's start our code. Okay, let's start by importing basic modules like numpy as np, and after that let's import pandas library as pd. Okay, all these two are imported. After it has been imported, let's run this. Okay, let's add a code cell, and then let's pd dot read csv. Okay, pd dot read csv data dot csv. I will be loading as a data frame using the pandas module into df. You can check what the df is. Yeah, so this is df. It contains, as you can see, it contains customer id, surname, credit score, and other information as well, and it is a prediction column that will be predicted whether the customer has exited or not based on his profile, whether he has credit card, number of products, based on his profile, whether he has exited or not. We will see that, and we will be predicting this. We will be predicting this column, and these are our input features, and this is the output column, and we will be building the model so that we can predict the exited column. So you can see that we have checked the data set. We have taken an overview of the data set, and let's df.info. Let's do a quick df.info and to check if there are missing values or not. As you can see, there are no missing values, and you can see all the data types. There is a surname is string object and int. So there are three strings which we might be have to do one hot encoding, because our machine learning model does not understand strings. So we might have to encode all this into numbers, so that our machine learning model is able to understand. Let's add a code cell, and let's check whether there are duplicates or not. Let's see that duplicated some. Okay, there are no duplicate values, there are no duplicate columns. Okay, and then let's see is the dataset is imbalanced or not. Let's see the structure. Let's see the count of the exited column. Dot value counts. Let's see this. Okay, as you can see, our data is a bit of imbalance. We will not be balancing the data, as our only purpose is to build the model, and that's our purpose for this video. In another video, we will be seeing, we will be trying to balance out the data, perform exploratory data analysis and other things, but the motto, the agenda of this session is to teach you how you can build your very first model. Okay. So, that is it, and then let's after we have checked the exited column, let's also check the gender, geography also, how they are structured. As you can, let's see. Okay, let's just copy this and paste it, and again paste it. We have pasted 2 times in a row. Let's gender. Okay, as you can see that the gender, okay, only gender is executed. As you can see, the gender is kind of balanced, fairly balanced. Let's see the geography column. Okay, there are 3 countries in the data set, and they are roughly balanced. Germany and Spain are balanced, not France. Okay, so let's just keep gender here, and then we might have to drop 3. Let's look at the data set once again. Df dot. Okay, so this is the data set. So, for building the model, we are dropping the surname. See as this does not, I guess this does not have an impact on the output column. As you can see, surname it might have, but for the sake of building the model, we are disposing the surname column along with customer ID. Is definitely does not have any relation with the output column. So, we are definitely gonna discard this column, else row number also same goes for row number, same goes for customer ID. Surname might have some relation with the output column, but in a general and common sense, surname might not leave an impact. That is why we are discarding it for the sake of just building the model, and let us discard all the 3 columns. How we are going to discard it? We are going to use df drop dot drop row number, customer ID and surname. It is given. As you can see, the in place equal to true. In place equal to true means we do not have to store this another variable, it will be done in place. In that variable it will be done, we do not have to it will not return any result, it will be done in the original data set. You do not have to copy in another variable to represent the new data set. And axis equal to 1 means we are removing the column after all. That is it, and let us run it. Let us add a code cell and let us see how the df is right now, how the data set is right now. Let us see. Okay, credit score, geography. Yeah, the 3 columns have been disposed. We have disposed the 3 columns successfully. Now let's what we can do, we can now one hot encode the categorical columns. What is one hot encoding? We will be representing the strings, as machine learning model cannot understand strings at all. We are going to convert the strings into numbers such that machine learning model is able to understand the numbers as well. That is what we are going to do. Let us try doing it. Let us try. Okay. Create dummies. We are using and columns, geography, and we are going to use gender. And drop first true. We are dropping the first column. We are dropping because of a topic known as the uh, what is what there is actually to for reducing the multicollinearity between data. That's an advanced topic. You can search it up. We are dropping the first column in order to reduce the overfitting. Okay, that's why we are dropping in one sense. You can tell that. So yeah, we are reducing the dummy variable trap. You can search it up on Google. What is that? There is also ChatGPT. You can search it up. What is dummy variable trap and look for it. We are basically doing this drop first equal to true to avoid the dummy variable trap. You can definitely look over internet. We will not be covering that. For now, you may know that it reduces the chance of being overfit. That's you may know that you may know that reduce and it makes a better model eventually. So that one kind of efficiency we are doing. Another thing we will be doing that we will be scaling down everything. What do I mean by scaling? Yeah, because you can see the balance is in 10,000 100,000. It's a different, there are large digits, but for age it is small, and for gender it will be 0 1 like that. Gender geography you can I will just write it. There will be numbers, small numbers, but the balance is very large number. So we will be scaling down and putting in a similar scale. So we will be doing scaling first to increase the accuracy of the model. We will be scaling to increase the accuracy. We will be scaling down our input data. So before scaling, let's just 10 test split. Okay, let's just 10 test split. One second, gender male, false, geography, gender. Yeah, they are actually represented by false. They are actually 0 0 0 0 1 0. Okay, one second. Yeah, they represent like that. It's not an issue. Let's at first what we should do. Uh, we should be transforming our data set into splitting our data set into 3 10 test. We will be performing 10 test plays basically. Let's do it without wasting any time. Yeah, we have taken the input features into in X and output column in Y. We have taken that. Let's run this cell. Okay, then what we can do? We can import from sklearn. Yeah, test split, and then they are coming. Yeah, we will be setting the test set as 0.2. This means that in the Y portion, in the test, and the test data set will be 20% of the total data set. This means it. And random set, we are basically using random set equal to, it's like a seed value. That means whenever you rerun it, it will not be changed. Means the selection procedure for Y data set, for the test data set, actually for the test data set will be same each time you will be running. If you remove this random state equal to 0, then every time it will be random. That is what it means, what this keyword means. Okay, means every time the test data set will be found from the main data set by taking random values. So, random values, I mean random columns out of the main data set. So, to prevent that, we are using random state equal to 0. Okay. And let us now scale our input data set. Haven't run it. Okay, we have import the standard scalar class, and we will be creating an object from the standard scalar class, and then we will be doing feed transform, the xtrain and the xtest normal transform. So basically, we are transforming, we are scaling down in a range, in an exact range. That's what we are doing here. Now let's run it. So what is an error we get? Could not convert string to float. This error might happen if we did something wrong here. Yeah, as you can see, this does not happen in place, and if you do in place equal to true, I guess it will happen. Rather, let's just update df. It will happen. Let's run all. Yeah. So the scaling also happened, and now let's without we have done every pre-processing things, then basic pre-processing things. Now we will be coming to the crux, coming to the main part of our video, that is model building. Let's import the basic libraries, that is import TensorFlow as TF from TensorFlow, import Keras from TensorFlow.keras, Keras from TensorFlow.keras. Yeah, will be TensorFlow.keras, import sequential, and from TensorFlow.keras.layers we will be using, not dropout, we will be using tens, and that's what we have done. We don't have to add TF, we don't have to do that because we are not using TensorFlow, we are using from, that's why we are importing. And let's, I guess it doesn't need the line, let's let it stay for here now, and let's just create another set. All the imports have been completed. Well, now now we can create our model. We are creating the model object from the sequential class, and then model dot add. Yeah, we are taking ReLU. Yeah, we can take ReLU for now. Let's let at first take sigmoid, the basic activation function, and then in the next video, not in the next after training, we will be testing things out, and that time we will be taking ReLU. And now input dimension equal to xsep equal to 1. Yeah, x dot shape equal to 1. Yeah, actually okay, it's okay right now. Then model dot okay, there won't be 120, there would be 1 only. That is, we are taking two models, actually two models. What I am saying, I am taking only one model, and inside that model there are two layers. So let's understand the architecture, model architecture, by drawing things out. We will be better understanding by a pictorial representation rather than verbally. For that, let's just draw things. Okay, let's understand the model by drawing. So there are 11 in total, there are 11, you can count, there are 11 input features, there are 11 input features, there are 11 input features. And there are 3 neurons, 3 nodes in the first layer. So what these 11 input features are doing, they are getting connected to each other like this, the basic neural network stuff, and everything is doing like that. And then this is the first layer, this is the first layer, and what will be the second layer? This will be the second layer, and in total you can count in total how many parameters are there for this For this there are 5 into 3, 15 weights plus 3, there are 18 parameters for plus 3 bias, 15 weights plus bias 5, actually not 5, there is I have taken it from, there will be 11 and 33, 36, because there are 11 input features, that is why it is 11, 33 plus 3, 6, 36. And for this second layer, what are what's gonna be the number of parameters? It will be it is easy to calculate. It will be 3 plus 1, 4, and that's it. We are using sigma in every layer, though we are going to change the activation function for this layer. Okay, after training, let's at first understand this architecture. Have you understood this architecture? I guess it's not too complex to understand. There are actually two layers, one two layers, and there is the input, there is the input coming from this input features. You can say that this is the input layer and these are the two layers, this is the output layer, and there is one hidden layer, you can say that, and then there are 3 nodes in it, and there are 36 in the first layer and 4 parameters in the second layer, and we are going to train the weights and biases we are going to find the correct value of this parameter. That's our motto. Okay, without, yeah, let's we have done this. We can do another thing, that is model.summary. We can check, we can easily check what we have done, the architecture. Yeah, this is the architecture, this is our architecture. Well, there are 144, I guess I have done some calculation mistake. 1 second, okay, 1 second, activation segment, then haven't I added? Oh, I have, actually here it will be 3, I am taking 3 nodes na, here it will be 3 nodes for now. Yeah, for now we are taking the total for 40 parameters, 36 plus 4. As you can see, it is actually it is right, we have calculated also. There is 36 parameters in the first layer and there is 4 parameters in the second layer. 36 plus 4 is 40. This matches with our pictorial representation of the architecture. Let's do one thing. Let's compile our model. The next thing we are going to do after creating the architecture, we are going to compile the model. What's compile? Compile is basically we tell the model some important things there. Let's see what are those important things. We are going to tell this. See what will be the loss function we are going to tell at first, and what are we going to use any optimizers or not, that's also we are going to tell, and what will be the matrix, in each epoch. Okay, that will be shown to us, that will also be told here. And then let's run this, and then we have to model.fit it, extend scaled, actually, yeah, we have taken the extend scaled, actually this is one. Let me check. Oh, this, oh, I have updated the extend. Okay, yeah, epochs batch size equal to 10. No, let's just use epochs equal to 10. We are using stochastic gradient descent, not batch gradient descent. We'll be taking each we'll be taking each in each epoch 1 and 2 and 3, everything we are going to do stochastic one. We will be taking each, what should I say, each row and updating it on the value, and that's what we are going to do. Don't be confused from that. This line just basically tells you that we are going to perform epochs 10 times, and based on the 10 epochs we are going to update the value. Okay, that's the thing we are going to do. And then actually it's I guess we are going to do batch gradient descent here. Okay, so don't be confused here, we don't need to be confused here. We are objective is to create the model. That is our objective. Let's just create the model here. Okay, that's our objective. And we are training the model. See, we are training the model locally, and then code. Let's write the next cell. What will be the next cell? We have trained the model. Our model has been trained in 10 epochs. As you can see, the loss decreases in each epoch. Okay, I have some question here. Can I ask? Yeah, let's ask. SGD here. SGD is used or batch GD is used. I have a question. Let's ask Copilot for that. SGD is optimizer is explicitly used. We are using SGD another optimizer stochastic gradient descent to look the compile by default. By default, what is default? Are we using batch GD at Adam? Let's see. By default, you are using mini batch size of the batch size. Non-specified Keras will use the default value of 32. Okay. So we are by default we are using mini batch gradient descent. Yeah, that was a confusion. I have also solved it, and you have also solved it. You don't have even you will not be, what should I say? You will not be confused by this gradient descent. What gradient descent is being used? As you can see that clearly that mini batch gradient descent is used explicitly, and by default 32 is the batch size. So we have cleared, and there will be no confusion arising from you. Let's just move on to the next section of the code. Let's see our prediction. You can see the our prediction. What let's just print our prediction. Okay, and let's see what prediction we will be getting here. You see that. Let's run it. Just run it. See, we are getting the prediction between 0 and 1 for each of the row, for each of the input column, input row. For each of the input row, input data, we are getting the output in terms of probability. So what we should do? We should be converting. We should be converting the output. If greater than 0.5, then it's true, means 1, means he or she has exited, else false, not exited. That we should be doing. Yeah, let's do it. np dot predict. Yeah, so we have done it. So what is it doing? It is checking whether 0.5, if it is 0.5, it is greater than the output prediction is, if greater than 0.5, then it will be returned as true, else false. This is what the line states, and it will be stored in y prediction. Okay, we have successfully created our model, and let's see our accuracy score. What is our accuracy score? Let's see. Let's see our accuracy score from a scalar. Let's okay, our accuracy score is coming 79%, which is not that bad. Why? Yeah. Okay. Now let's try to improve our model. So what can we do to improve our model? Okay, to improve our model, we can add more number of layers in our neural network. We can change the sigmoid activation function in the hidden layers to ReLU, and we can also add other things as well, but for the sake of this video, these two things are great and fine. So we will be adding more number of layers, and we will be also changing from sigmoid to ReLU for our activation function. See, I have already done it and already added the number of another layer, and also I have increased the number of nodes in each layer and also changed the sigmoid in the hidden layers to ReLU. These things I have done, and other thing that is yeah, I have copied, yeah, I have used validation split equal to 0.2. What it is doing, it is basically using validation data. What is validation data? The data which is taken from the train, from the actually from the training data set. If some portion of the training data set is taken as validation data, and it is used continuously in each epoch to test things out, to test along with the training data, but also with the validation data which the model hasn't seen yet, and it actually tells the actual performance of the model. And that it is doing that, what it is doing, see, it is telling us the validation accuracy for each epoch, and see, and after 100 epochs we have run. See, the validation accuracy is 85%, which is actually good, and the loss is also decreasing with each epoch. Validation loss, the validation loss and validation accuracy are the real thing, are the main thing, because it tells how the model will perform on the unseen data. And then we have done all the things. Yeah, I have also added matplotlib. You can add matplotlib in the requirements. You have I have added and installed before, but before I haven't added there and installed there. I have added matplotlib here, and then I have used history loss. I have plotted loss and validation loss in one graph, and accuracy and validation accuracy in another graph. As you can see, the losses are close to each other. Validation loss and normal loss is close to each other, training loss is close to each other. So, what it means? It means that the overfitting is very much less, and also as you can see from this graph, the accuracy, the training accuracy and the validation accuracy one, you can see that the overfitting is also less from this graph. And that's it for now, and hope uh, and that's it for now. Let's in this video, to summarize, you learned many things. You learn how to load the data, how to download, how to load the data, how to set up your Visual Studio Code to run Python notebooks, and then you learned how to load the data set into pandas data frame, and then you learned some basic pre-processing steps, non scaling, and then you learn how to encode strings into numbers, and then you learned how to create your own model using Keras, and then you use model.fit to train the model, along with some basic improvement tips and tricks you can perform in your own model. And also we used matplotlib to graph our plot, and also we learned the use of validation data. And that's it for now for this video. If you like this type of content, if you like this, first of all, if you like this video, kindly press on the like button, and if you like this kind of content, consider subscribing to our channel, and we will meet in another video.